Hi, I'm Dr. Derek Wilson with TrekAi, and I'm excited to share with you today a little bit about what is AI and what is it not. So, as we start talking about artificial intelligence, what are we actually talking about? So, a couple of things. What is AI? AI is, I think the best way to think about it is as a giant probability machine. And I think that's more than anything I would want you to walk away with is this, is that large language models like Claude or ChatGPT or Trek, all of these large language models are guessing machines. And so they learn patterns. Now, there's some tools that AI can use to look up things, but when you ask a question to an AI, it's not looking up the information. It's simply guessing. And it's the best guesser that has ever guessed in the history of guessing, but that's what it is. It's guessing. It is a tool, so because of that, it's simply guessing or predicting the next best word. And it's a helper. It's also helpful. It can help people learn and work faster. What it's not conscious. It's not a human. It's also not always right. It can make mistakes. And when it makes mistakes, we call that a hallucination. AI is also not magic. It's math. The best way I always think about it, I like to think about it, they call them neural nets, and that's because it really is this net of dependencies. That what happens is as I get more information, the net adjusts and it becomes. But it doesn't look anything up. AI does not know anything in the traditional sense. It simply is able to guess well. Okay, so let's define some terms here. Artificial intelligence is this broad category. And before, what we have now is artificial intelligence was really just like programmed. And so if you wanted to say like, if the user says, what time is it? Pull up the image of the clock. But the programmer would have to say, if the user says, show me the clock. If the user says, what time is it? Without a question mark. If the user, it has to think through all the eventualities. It's just really unwieldy and not possible. Then we started doing machine learning. Machine learning are these deep algorithms that they're a lot like TikTok feed or your Instagram Reels feed or Google. Like there are these algorithms that run behind the scenes that say people who watch a lot of this tend to like this will go down that path, right? And that's how that works. Then you have one lower level, which is deep learning, which are these neural nets that I was just discussing. And inside of that subset is LLMs, or large language models. These are chatbots. They're incredibly flexible. Other ones that would be deep learning are things like computer vision. So like if you have an iPhone, the face unlock, machine learning would be the recommenders, and then voice to speech would be another subset of deep learning inside of that. So this is how it works. Like I said, they're giant predicting machines. And one of the things that revolutionized things and OpenAI's big jump forward was in this predicting mechanism. So, for example, on your phone, when you type in something, if you have an iPhone, it'll predict the next word. And that's usually because it's looking at the previous two words. What made ChatGPT, which was the first big LLM that really hit the market, was the ability to look not just at the previous word, but at the previous 1,000 words. And so that made its prediction even more accurate and helpful. That it didn't just look at cat sat on the, so for your phone, would just see on the, and that you can't really predict. But if you see cat sat on the blank, you could predict. And so what you get is this idea is that if we asked billions of people to predict what the next word is when they see cat sat on the blank, we would see a distribution a lot like this: mat, rug, floor, hat, right? But there's certain things we would never see, right? We would never see a human say, yeah, the cat sat on the blue, period, right? Or cat sat on the A, right? Like that's not going to exist. And so what OpenAI did was this idea of reinforcement through learning human feedback called RLHF. And so what this does is this. First of all, they run tons of text. Really, the entire internet, right, is what they did. And they run it through. And they have this thing that comes out. And when it's first in this stage, it's pretty good. You could chat with it, but it's kind of wild too. And so what they have to do then is fine tuning. They start giving it more and more examples, right? These kinds of things. And then they do RLHF, reinforcement learning through human feedback. And what they do is they show humans something like this. Cat sat on the blank, mat, rug, floor, hat, and they rank these. And so it starts ranking. And eventually you rank more and more and more until it starts to understand how humans actually think. And so when you're doing this RLHF, what they do is this. They create a reward model that learns what humans like to hear and what sounds good to humans. And then they come back and they use that to fine tune this first process here. And so what happens is RLHF, what it becomes, that model is a reward model. And so its sole job is to determine sounds like a robot or sounds like a human. And then when the ChatGPT, the first model, outputs, it says, oh, you sound like a robot. And so it readjusts itself. And then it says, oh, you still sound like a robot. Readjusts itself. It says, you sound like a human. Great. It moves on. And it does this trillions and trillions and trillions of times over and over again until it starts to always sound like a human. This opens it up to some issues. One, humans are predisposed to wanting longer responses. They're predisposed to thinking longer responses are correct. And so because of that, that's one of the reasons, if you'll notice, ChatGPT, Claude are really long-winded. And it's something us in Trek that we work actively to make our responses shorter because of that. The other thing is in this RLHF phase, the humans are fallible and they're not looking for what the right answer is. Maybe the human doesn't know, but they know about what sounds right. So the American Independence Day was July 4th, blank. And then they see 1776, the correct answer, 1992, 500, and 1777. So what's going to happen is humans are going to know it's not in the 1990s. They're going to know it's not in the 500s. But maybe some humans don't know if it's 76 or 77. And so because of that, it gets these inaccuracies into its system because it isn't able to know or look up something. And when it guesses wrong. We call that a hallucination. On top of that, we have what's called here tokens. AI reads differently than humans. While we read in words, they read in tokens. AI reads in tokens. And tokens often is a word, but sometimes it's 3/4 of a word. And what happens is they start to have what's called a context window. And that's the amount of memory that it can hold in it. Remember, I told you ChatGPT looks at all that came before it to guess the next word. We call that its context. And it's just like humans limited. Just like you have a working memory, you can only hold so much in your brain, so can these large language models. And so when you start to notice something like Trek or Claude or something starts to kind of like degrade a little bit, it's often because it's hitting its context window. Now, this context window has gotten bigger and bigger over the years. It's not as much of an issue as it was in our early days. Awesome. Thank you so much. I'm really excited that you're here. Thanks.